Hello, everyone. Today we're doing a few things here. We got quite a messy kitchen. Ava's doing arts and crafts. Deep cleaning a customer's machine in the background, so I apologize for the noise in advance. But it's important to do an annual deep clean of your ionizer to ensure that there's no mineral buildup on the plates and to make sure everything's functioning correctly. So we're taking care of that for her right now. In addition to that, she sent us a sample of her water, so we're going to do a few tests here today. And the first thing we're going to test is hardness. So we want to test hardness to see, the one condition of the water, how hard it is. Typically, it's calcium that's in the water, but it gives us a good indicator of how quickly or how often we should be doing a deep clean on our ionizers because calcium buildup can collect on the plates and degrade the performance of the ionizer. The other thing is just making sure that we have clean water, and we're going to test total dissolved solids. We're going to test pH, and we're also going to test chlorine. So stay tuned. Here we go. So the first thing we're going to do is we're going to fill this sample tube with the water from her tap. This is unfiltered, so it gives us an idea of what we're dealing with straight from the municipality or from her private well. We're going to pour it in this square jar here. Then we're going to take our solution number 1. We're going to put 3 drops of that in here. 1, 2, 3. And then we're going to swirl that around. Then we're going to take solution number 2. 3 drops again. 1, 2, 3. Now we wind up with a nice magenta, purpley, kind of pinkish. What color is that, Ava?
Violet.
Violet. Okay. We'll go with violet. I think that's more like a pink, though, right? All right. Now we have solution number 3. Our indicator now, we're going to go by drops. This is going to tell us how many grains per gallon, which will then convert to ppm, how hard the water is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're looking for a color change back to blue. That was 10, and we have no color change. We're going to add another 10 here. 1, 2, 3, 4, 6, 7, 10, that's 20. Just careful. All right, we're going to swirl that around. We have 20, no change there. So now we're going to go by 5. So we'll do 1, 2, 3, 4, 5. Give it a swirl. 25, nothing. 1, 2, 3, 4, 5. That's 30. She's got some pretty good hardness here. Most likely doesn't have a softener. We will confirm. 1, 2, 3, 4, 5. 35. And 1, 2, 3, 4, 5. Puts us at 40. And there's our color change to, now we have violet. Oh, now blue.
Yes.
Quick violet, then it went blue. So 40 grains per gallon. That is hard water. I would recommend a softener or an ion exchange pre-filter before going through the ionizer, just to help prevent any calcium buildup on the plates, any premature buildup going for that. So if you notice a lot of white residue inside your water bottles, white little speckles floating around in your water out of your ionizer, it's a good indicator that you have a lot of calcium in your water, and ion exchange is meant to remove that calcium. A water softener is ion exchange. It takes calcium out of the water and replaces it with low amounts of sodium, very low amounts of sodium, but that's how ion exchange works. And a water softener will then regenerate. That's why you need salt to wash that calcium back off the resin beads and start over. Okay, our next test, we're going to look at, you know what, let's do this one for pH. And I'm going to grab a smaller cup here. So we'll use less of the water. Let's take a color indicator for pH as well as chlorine. Take some chlorine drops. 1, 2, 3, 4, and 5. And that's already turning yellow. So it definitely has chlorine.
Greenish yellow.
Yeah. Definitely has chlorine in the water. And let's take a look at this. This should be a green. Green is neutral for pH. She's on city water. Yep, that looks good. That's a green. On the slight bluer side, but that we'll call that neutral. And that's a green, slightly over 7, we'll say. So that's okay. This, however, is a nice yellow, which is what we don't like to see. We like to see clear for that. Now, I'll do a quick demonstration of you why we don't want chlorine in our water. So you can see I put some test strips there. I'm just going to take my fingers here. I'm going to put my fingers in here. I'm going to swirl them around for a little bit. And the reason why we don't want chlorine in our water is because it absorbs into our bodies. Now, chlorine is required in many municipalities for killing all the harmful bacteria, any nasty viruses, bugs, things like that in your water source on your way to your home. But in the process of doing that, it creates what's known as disinfectant byproducts. And disinfectant byproducts are known carcinogens. They can cause cancer. So you don't want that same disinfectant going into your body because it can be harmful to your body as well. So we like to remove that chlorine. Now, what I'm doing here is just simulating maybe taking a bath or a shower. And this was about 30 seconds. I'm going to go ahead and test and see if there's any chlorine in this water. And I put more than enough drops in there. And as we can see, that water is clear, meaning all the chlorine that was in that water just went into my body that quickly. So a 10-minute warm shower, your body will absorb more chlorine than drinking 8 ounces of that, 8 glasses, 8-ounce glasses, so 64 ounces of that same water. So keep that in mind, when you're washing your fruits and vegetables, when you're taking a bath, taking a shower, and drinking it. Try to avoid that. So we will certainly recommend a filter for reducing the chlorine as well as reducing the hardness to optimize their machine. The other test I do want to run real quick is total dissolved solids. Now that does correlate to the hardness. So we are going to check that for her real quick. And typically what that'll do is it'll give us an indicator of if there's anything else going on. We'll convert the hardness to ppm, and then we'll take another look and just see what else might be going on. So this is on the higher side, which is expected. We're getting about 448, 450 ppm. I would expect that the majority of that is coming from the hardness in the water. So we'll do the math there for her. We'll do the conversion, take another look, see what else is going on, and we will go from there. So that's all I have. And if you have any questions, if you're interested in getting your water tested, please reach out. Go to healthyh2osolutions.com, where you click the link in our bio. Hit subscribe if you like this. Go ahead and hit the like button, and we'll see you in the next video. Take care.